Hello, this is Mrs. Moslick, and these are notes for geometry, section 10.8, the preview to equations of circles. Do the 2 warm-up questions. When you are done, go ahead and play this video again. But right now, go ahead and pause. Okay, for warm-up number 1, you should have gotten 13. And did you use the Pythagorean theorem? If so, go ahead and skip. If not, go ahead and watch. So 2, -7 and 7, 5. Plot those 2 points and then draw in your horizontal and vertical lines and connect those 2 pieces, line segments, connect those 2 segments with a line segment. We'll call this C and then go ahead and count spaces here. Horizontally is 5, vertically is 12. So we have 5 squared plus 12 squared equals C squared. So we have 169 equals C squared. Take the square root of both sides, show that you're taking plus or minus, but our final answer is just the positive value since it is a length. Let's go ahead and now find the distance between those 2 points using the distance formula. And so distance formula is D equals square root of the quantity x2 minus x1 squared plus y2 minus y1 squared. Label your first point x1, y1, second point x2, y2, and plug in your particular numbers. So we have D equals square root of the quantity, 7 minus 2 squared, plus 5 minus a -7 squared. So distance equals square root of 5 quantity squared plus 12 quantity squared. Simplifying that, we have D equals the square root of 25 plus 144, which is the square root of 169, which is also 13, which we found above. So you can find the distance between 2 points either graphically using the Pythagorean theorem or using the distance formula looking at the points. Let's go ahead and use those 2 same concepts to come up with the equation of a circle. And so we'll use the Pythagorean theorem. We'll also figure it out by using the distance formula. And let's go ahead and just look at the definition of a circle. A circle is a set of all points in a plane that are equidistant to a center point. Now, the center point we will always call h, k. So equation of a circle. First of all, center point is going to be h, k. And the distance between that center point and any point on the circle is the radius. So the radius, we'll just call it r. So let's go ahead and derive it using the Pythagorean theorem. So we'll write down Pythagorean theorem. And the Pythagorean theorem is a squared plus b squared equals c squared. So let's take these 2 points, and just like in example 1, to find the distance between 2 points on a graph, draw in your horizontal segment and your vertical segment, and write down a right triangle. And we want to find the length horizontally and vertically. So think about what that length is horizontally. That x value is h, and this x value is x. So the distance between those is big minus small, so x minus h. Vertically, the big y value is y, and the small one is k. So that distance, big minus small, is y minus k. So just replace a with x minus h. Replace b with y minus k, and replace c with r. That is your equation of a circle. So equation of a circle has center hk, radius r, and the equation is x minus h quantity squared plus y minus k quantity squared equals r squared. So this is the key for this, this section, equations of a circle. Now, a lot of times it's nice to know a different way to get that same formula. And so let's derive it also by using the distance formula. Distance formula. It's just, remember, what is a circle? It is the set of all points in a plane that are equidistant to a center point. So our distance formula is d equals square root of the quantity x minus h squared plus y minus k squared. So that distance is r, and that equals the 2 points. Let's say this is our first point, x1, y1, and our second point is x2, y2. Replace here, this should be x2 minus x1 and y2 minus y1. And we're replacing the d with r, the x2 with x, and the x1 with h. And we're replacing the y2 with y and the y1 with k. Square both sides, so you get r squared equals the quantity x minus h squared plus y minus k squared. And it's the same formula as above. And so we just derived the equation of a circle into methods using the distance formula and using the Pythagorean theorem. Let's go ahead and use the formula for an equation of a circle to actually come up with equations of a circle or circles that are already drawn. Let's look at the back side. And so first of all, the general equation of a circle is the quantity x minus h squared plus the quantity y minus k squared equals r squared. The head, that's interesting that showed up there. The head's center point is 0, 0, and the radius is 7. Let's just go back and see that. So the head, this is the center, and the radius is 7. Now the eye center point is what? -3, 4, and the radius is 2. This point is 3, 4, radius is 2. The nose is at 0, 1, and the radius is 1. And the mouth has a center of 0, 1, 2, 3, 4. So 0, -4, and the radius is 3. So we'll mark the chart with all of those points. So we have 0, 0, and the radius is 7. And then we have our next, the left eye is -3, 4. The radius is 2. The right eye is 3, 4, radius is 2. Nose is 0, 1, radius is 1, and the mouth is 0, -4, and the radius is 3. So the specific equation for the head is the quantity x minus 0 squared plus quantity y minus 0 squared equals 7 squared. You can keep it that way, although don't keep the 7 squared, write it as 49. Also, instead of x minus 0 squared, you can just put x squared. And instead of y minus 0 squared, you can say just plus y squared equals 49. This is a more simplified version. Left eye, x minus a -3 quantity squared plus y minus 4 quantity squared equals 2 squared. But instead of writing it as 2 squared, let's write it as 4. Right eye, x minus 3. Oh, I think I wrote this one. This should be minus a -3, which is plus. X minus 3 quantity squared plus y minus 4 quantity squared equals 2 squared. Again, write it as 4. The nose, x minus 0 squared, you can just write it as x squared, plus the quantity y minus 1 squared equals 1 squared. And finally, the mouth, x minus 0 squared, or just write it as x squared, plus y minus a -4 squared, which is y plus 4, equals 3 squared, but write it as 9. So we have our 5 equations. We're going to now type it into Desmos and come up with the same picture as we had here.